So welcome in the lecture series of numerical methods using C++. So here we are going to study our numerical methods with the help of C++. So why are we going to study the numerical method in this lecture series? Because this is going to be a long lecture series. Because numerical methods has numerous of applications. And there is not one numerical method, but there are a variety of numerical methods. Some of them are finding roots, some of them for finding partial differential equations, the solution of the partial differential equations. Some of them are going to find solution of integral equations. So there are various numerical methods, and that have different kinds of applications, especially in those areas where exact solution is not possible. Numerical methods are going to be a very useful tool for that. So let's say if I talk about the CFD using the finite volume method or finite element methods or finite difference method is going to be very useful. In similar cases in other research areas like structures and all these areas, numerical methods are going to be a very useful tool. So in this series of lecture, we are going to discuss not all but few of them are very important numerical methods. So in that series, first method is method of bisection method, which we are going to discuss today. Bisection method. So what we are going to learn and what will be the root of our discussion. So first we will see what is bisection method and what is its purpose. What is bisection method and why we are going to use it. Second part is we will discuss algorithms, what we are going to implement in the bisection method. And third, we will actually code. So in this lecture we will cover these two points, and in the next separate lecture we are actually going to code in the C++. So in the way you will also learn the fundamental concepts of the coding also. But our main focus will be in the numerical methods. But of course I will discuss whenever required the concepts of the C++ also. At the end of this lecture series, what you are going to get, you will be familiar with the C++, first thing, and second you will be familiar with the numerical methods. These two tools are basically required if you go to the further advanced study in any domain like CFD. So in future you can develop your own codes. Let's say in the case of CFD you can develop your own solvers using these methods. So this is the broad motivation for this series. So first is the bisection method. First we are going to learn what is the bisection method. So let's say bisection method is a tool to find, or it is the algorithm to find a root of the equation or polynomial, you can say, roots, where it is going to be helpful to find the roots of the polynomial which is continuous in the nature. So let's say any polynomial f of x, say for example x cubed minus 2x minus 2, and we are going to find the root of this polynomial. What is the meaning of root of this polynomial? Root means, although you know this is a very fundamental concept. Root means at what value of x the function should give the value 0. So let's say at particular value of x the function becomes 0. So that value of, let's say any value, let's say a, x is equal to, if you put x is equal to a, this function is 0, then a is your root. So by the graph we can understand the algorithm better. So I will try to explain with the help of graph. So let's say this is the function and this is the value of x, and the function is behave like this. And here the function value is 0, this is the f of x, and this is x. So this will be root. And what is the algorithm? First thing, we need to guess two values. Guess two values of x. And what is the condition? Condition is these two values give a different sign of functions. That means, let's say if the value is a and b, then if f of a is negative, then f of b should be positive. Or we can say in other way, f of a into f of b should always be negative. So this is the condition for our initial guess, and this holds true in every iteration in the bisection method. So let's say I am choosing a and b like this. This is f of a, which is negative, and this is f of b, which is positive. So this is our initial guess. Now next, in the second step, what we are going to do, we will calculate a plus b upon 2 and store in another variable, let's say c. And now we are going to check if f of a and f of c is negative, that means product of f of a and f of c is negative or positive. If it is negative, that means a and c are f of a and f of c are giving a different signs. So that means the interval will be lie between a and c. Previously it lies between a and b. So we need to replace b with c. So we will say b is equal to c in the coding. But for understanding, we can say that now the interval will lie between a and c. And again we will repeat this procedure for interval a and c. So let's say I am plotting it here. This is the value of a plus b upon 2. Let's say this is the c. This is the c. So now you can see fc is positive and fa is negative. So that means now the interval is between a and c. And gradually you can see here we are approaching towards our solution. Now in the next iteration, again in the interval a and c, we will do a plus c upon 2. Let's say this is d. And again we will check whether fa into fd is negative or positive. If it is negative, then it's good A and D. If it is positive, then definitely it will be between C and D. So deciding the interval is important here. And how we are going to decide? We need to keep in mind that these two intervals give a function value in opposite sign. Right? So this is the algorithm which is we are going to implement in the C++. And let's say in the perspective of coding, how we will implement this equation. So in the perspective of coding, what we will do, first we will guess A and B. The condition is same. F of A into F of B should give negative value. And now we again calculate C is equal to A plus B upon 2 and check if F of C is equal to 0, then this is your solution. If it is not 0, then we calculate the product of this, and if it is less than 0, F of A and F of C product is less than 0, then that means interval is between A and C, so we need to update B. So B is equal to C. Because every time for the coding we are considering the interval A and B, because we will code in this way. Okay, so B value equivalent to the C value, because interval is in between A and C. Now again, if it is not true, if this condition is not true, then the interval will be between B and C, and we will update A in that condition. A is equal to C. And this loop will be continue till now we meet the certain condition. What is the condition? Absolute value of B and A, difference of B and A should be less than certain value, which we call the tolerance. So up to when it is greater than of certain value, then loop will continue, and when it is less than certain value, then loop will stop. So this loop should continue when absolute value of B minus A should be certain tolerance, let's say epsilon, and we will give the value of epsilon 0.0001, whatever you need. So this is the algorithm we are going to follow in the C++ coding, which we are going to cover in the next lecture. Thank you.